day. I'm sure somebody want a few beers afterwards or something. This is a really good presentation. We've been working with Tim and Pitcrew for 2 years now. Some great work across mining. They've been developing their position and their solution for on-road as well. And we can see that, I think one of the use cases in here, or one of the case studies in here is an actual on-road, long haul, lots of trailers, operator that really puts their equipment to the test. So we're looking forward to hear from Tim. And again, as all these presentations, if it's an urgent question, ask it. Otherwise, we'll also cover it at the end. Over to you, Tim.
Yep. G'day everyone. Yeah, absolutely. If you've got any questions throughout, just shout out. I'm happy for this to be as interactive as we like. It's a small room, the benefit of that. So I'll probably start off preaching to the choir with some of these sort of stats, but just talking about heavy vehicle safety. A small percentage of vehicles on the road are heavy vehicles, and a disproportionate number of safety events are linked to heavy vehicles. The majority of crashes are linked to driver issues like fatigue and distraction and speeding. But there's mechanical faults that are also a major contributing factor, and mechanical issues in percentage rates are some of the deadliest failures we see in heavy vehicles. Non-impact fires, so wheel end fires and things like that, have doubled between 2021 and 2023, driven by preventable wheel end issues. So we've got a graph up there at the side showing deaths related to heavy vehicles, the majority being of light vehicle operators. So it's somewhere between 2 and 10% of, depending on the year. So the good quality data goes back about 10 years on this stuff. It lands between about 2 and 10% of heavy vehicle incidents relate back to a mechanical failure of some kind. The majority being related to tyres, brakes and bearings and wheel off issues. They are still rare comparatively in terms of incident rates, but they're more frequently deadly. In New South Wales, Transport for New South Wales released some data a few years ago showing that 1 in 4 trucks has got a brake defect of some kind. So really high rates of brake issues on trucks. And over the past decade, we're talking about 200 or so deaths have been linked to mechanical heavy vehicle accidents. So it's a pretty meaningful road toll there. So talking about like wheel end and heat issues. So 60% of your wheel end fires start with tyres, so things like underinflation or friction and rubbing. Bearings and brakes is your next biggest contributor. So again, that's stat around a doubling of those rates over the years between 2021 and 23. Your trailer wheels are more prone to these issues than prime movers because of the braking technology and the maintenance regimes. Tyre fires are almost impossible to stop once they're live on the side of the road. So at the moment, our inspection regime is, the industry has improved a lot, but the technology that we're expecting our drivers to use to be able to inspect for these things, walking around and tapping tyres and putting their hands on things to see what's hot and using their nose, it's just not suitable for picking up a lot of these issues. So there are a lot more proactive inspection technologies coming online. So things like handheld thermal imaging cameras and pyrometers, TPMS sensors, which can be their own challenge when you've got so many wheels on these vehicles, automated hubs and different sensing technology. But often when they're distributed on vehicles, there's a whole lot of maintenance issues. Even in a well-run fleet of that sort of telemetry and sensors, you might have 60 or 70% of the sensors actually online at any given time. The rest of them are dead or there's something wrong. So none of these things are perfect. Minor issues can escalate into pretty catastrophic outcomes. So dangerous goods transport is where this can have really, really significant impact. So potentially a lot of you in this room would be aware of this incident. Over the last decade or so, there's been about 5 major A&E explosions in Australia. This was one of the more recent ones outside of Gruyere mine in Western Australia. Rather than me try and explain it, there is a short video which will hopefully...
Where's the truck? On Sunday, the 23rd of October 2022, a road train was filled with ammonium nitrate emulsion at Kwinana. After filling, it then departed for Gruyere mine site. The driver rested overnight near Leonora, approximately 300 kilometres from the incident scene. After completing his pre-start checks on the morning of the 24th of October, the driver continued the journey to Gruyere mine site. The driver was travelling on a gravel road when at approximately 9 a.m. he joined two other trucks near Cosmo Newberry, a remote Aboriginal community. At 9:30 a.m, the driver notices black smoke coming from the rear wheels of the rear tanker. He notifies the other vehicles in the convoy by two-way radio. It is thought that the tyre fire was initiated from a leaking air supply line, causing brakes to lock on and overheat. The driver pulls over the vehicle and attempts to extinguish the tyre fire. At one point, he lies on his back to get better access to extinguish the flames.
More keen than most people.
The suspension bursts on the truck, causing it to drop in height, at which point the flames are now approximately 45 centimetres above the mudguards. The driver radios the two other trucks nearby, explaining that he is going to leave the scene. The other vehicles notify emergency services of the situation. The driver disconnects the rear tanker trailer. He observes the smoke is thick and black. At approximately 9:50 a.m, the driver leaves the scene and sets up a barricade on the eastern side, blocking traffic at the turnoff to the mine site. At this stage, a hole is beginning to form in the shell of the aluminium tanker trailer. At 10:05 a.m, the driver observes white smoke coming from the fire. The ammonium nitrate emulsion flows onto the ground. It becomes constrained by the topography of the road and pools beneath the tanker trailer. It is affected by the fire and starts to decompose, producing white smoke. The mine emergency response team arrives at 10:50 a.m. At approximately 11:05 a.m, the emergency response team enters the barricaded area to within 1.3 kilometres of the fire. They warn and escort out a motorcycle and a car that enter the area from the western side. While within the barricaded area, the emergency response team observes the tyres at the front of the tanker trailer are alight and flames are engulfing it from the ground. The smoke plume is approximately 20 metres high and the colour is changing from black to white. At 11:33 a.m, there is an explosion. The emergency response team see this and capture photos. The smoke plume is estimated to be 1 kilometre in height. Following the explosion, the scene was examined by first responders and then department investigators. The tanker trailer was completely destroyed. A crater was formed in the road as a result of the blast. It was large and shallow, with the deepest point being approximately 1.1 metres deep. The fire melted a hole in the aluminium tanker, causing the ammonium nitrate emulsion to flow onto the ground. The fire decomposed the A&E and burned the fuel component of the emulsion. It was molten sensitized ammonium nitrate, which then exploded. The size of the blast is estimated to be 1 to 3 tonnes of TNT equivalent. At 50 metres from the epicenter of the explosion, 7-metre high trees were snapped at ground level. Aluminium and steel shrapnel was found scattered predominantly to the southeast of the road, indicating the explosion occurred towards the rear of the tanker trailer. Following the investigation, a number of recommendations were developed to improve the safe transport of ammonium nitrate emulsion and similar products. These include control measures to prevent and mitigate tyre fires, which may lead to an explosion.
So, pretty full-on incident, because it is one of the more recent ones, there was a pretty thorough investigation into this one. Some of the recommendations that they mentioned there at the end were things like the proactive technologies like your TPMS and pre-screening using thermal imaging cameras and things like that. The crazy thing about this incident is, we are seeing one of these about every 2 years, so it's likely to happen again. And if anyone knows, where this stuff gets shipped from in WA, these tankers are going through CBD Perth. There's no other way for these vehicles to travel. So it's a major risk for any operator transporting DGs. So just I guess predominantly my background has been in mining, and so where did Pitcrew come from? It was a mining industry related application. Primarily looking at rigid dump trucks on mine sites. And a big part of that was as the mine sites started to remove the drivers from haul trucks and go to driverless systems, there were a whole bunch of maintenance issues that started to present on the trucks that they thought they'd overcome years ago. So things like tyre fires in this case. And for the last 20 years, one of the best control measures for tyre fires was literally drivers smelling burning rubber at shift change, and you'd get a day or two's warning and you'd get the tyre bay in and change a tyre before you actually had a fire. As you had the tier 1 start to remove the drivers, you started to see an uptick in the rate of tyre fires, and they were losing haul trucks to tyre fires for the first time in years. And so in the road freight industry, we can look to mining as, you know, literally the canary in the coal mine on this stuff. As we start to look at driverless technology and remote driving technology, we need to be supporting that with remote sensing technology, you know, to improve our maintenance practices in line with any of that sort of technology. So there's, in Australia, our standards are lagging some of the rest of the world. So the Automated Vehicles Act is out of the UK, and it's introducing terminology like any automated system must outperform a careful and competent driver. And I think we can reasonably expect that as the technology starts to be adopted in Australia, you know, if we're all looking forward 5 or 10 years, as that technology starts to get adopted, we're going to have similar sort of standards placed on us. So we need to be thinking ahead that, you know, how can we outperform a careful and competent driver? So that'll include everything from, you know, your pre-start checks, how do we replicate that stuff with technology? So from an engineering standpoint, it's all about getting ahead of the PF curve. So when does that failure start to occur? When is it detectable, and when is it a functional failure of that component? And the further we can shift the detection of that potential failure forward in that curve, the PF time, we can reduce risks, we can decrease repair costs, we can lower the risks of downtime. So what can we do to sort of push that PF curve back towards when failures are first starting to occur? As I mentioned before, no single system is perfect. So I'm not going to stand up here and say anything we've developed is perfect and is going to detect everything. You know, all of these things need to be layered on top of each other. It's that classic safety systems, holes in the cheese analogy. So what, in our operations, to meet our, you know, our responsibility for keeping our drivers safe, our chain of responsibility and keeping public road users safe, our duty of care there, how many layers of controls do we need to put in place? And they might be human controls, engineering controls, or technological controls. So I'm here to talk about thermography, which is thermal imaging, as a tool for this. In mechanical inspection, in my view, thermal imaging is a really incredibly effective tool. So you're visualising heat. Anything above absolute zero, so minus 273 C, is emitting some thermal radiation. And basically any mechanical system, if it's not functioning right, is either going to be getting too hot or too cold. There's either going to be friction or it's going to be cold because it's not working. So in terms of mechanical inspection, thermal imaging and thermography can be an exceptionally useful tool in terms of predictive maintenance and failure prediction. So our on-road truck system.
Pitcrew AI is transforming how safety and compliance inspections are performed on heavy vehicles. Undetected failures lead to breakdowns, costly downtime, and safety risks. Our Pitcrew solution helps identify issues earlier, improving preventive maintenance, safety, and compliance. Unlike a manual walk-around check, Pitcrew's AIS checks every truck as it drives through, with no need to stop. Using thermal cameras, it scans the tyres, wheel hubs and brakes from both sides and underneath, detecting problems automatically any time of day. It runs 24/7 without human input, finding issues early so they don't lead to breakdowns or accidents. The AIS is set up at the entrance to a yard, depot or weighbridge. Trucks drive through like normal, no stopping needed. As each truck rolls through, it scans every axle. The data is sent straight to the cloud, where Pitcrew's AI instantly checks for problems with tyres, wheel hubs or brakes, all without stopping the driver. Inspection results are processed in near real time. Alerts are then sent via email or SMS when faults are detected. Detailed inspection records are also displayed on the client's Pitcrew AI dashboard, allowing maintenance teams to review issues quickly and schedule repairs before failures happen on the road. By eliminating manual inspection and the challenges of inspecting behind dual tyre assemblies, Pitcrew AI reduces the risk of missed faults and human error. With 24/7 automated inspections, fleet operators can prevent roadside breakdowns, improve safety, and protect their reputation. Pitcrew AI, insight beyond sight.
So basically, as we just talked about there, what we're using is some high-end thermal imaging cameras. We partner with FLIR for the thermal imaging cameras we use. One located in the road surface and then one on either side. So the camera in the road surface is able to detect brake issues and inner tyre sidewalls, and your two side cameras are looking at wheel ends and hubs and outer tyre sidewalls. So able to pick up everything from underinflation through to brake asymmetries, bearing issues, basically anything that's causing undue heat or more likely than not an asymmetry between the wheel ends. So this is, I guess, something like what the dashboard would look like. So assets shown. Here we've got a very high temperature on a brake. So we're getting a low risk based on that 168 degrees, and then a difference temperature left to right on that axle of 130 degrees. So that's deemed as a high risk. Because it's, brakes can get hot, and there's nothing wrong with brakes getting hot, but they should be getting hot fairly equally. Otherwise, there's potentially something going on with the vehicle. So we're picking up preventative maintenance issues well in advance of when this stuff would be getting picked up by a technician. The dashboard, here we've got a cracker of an underinflation event happening. Ideally, you're not seeing any tyres that hot. The dashboard it's useful if you've got an operation where you do have a remote operations centre or a workshop. But the majority of our users would be interacting with it based on SMS alerts coming straight to their phone and getting out in the field and having a look at things. It's all about using that data to improve the efficiency of the operation. So here we've got a brake fault example. So you can see the red dots down on the timeline indicating where issues have been detected. You can see that asymmetry as the hot brake comes through. What's we got in here? Tyre underinflation event. So you can see a lot of heating at the shoulder of that tyre sidewall. Again, TPMS is probably the better technology for detecting underinflation. But in situations like this where you might have 90 plus wheels on a road train, TPMS is just not economically viable. So doing things like this is a good way to be picking up on that stuff much earlier than you otherwise would be. So in terms of who we're working with at the moment, we're working with regulators, we're working with private operators. From a case study of how the regulators are using it, it is as a pre-screening tool for brake force roller tester. So the way that would work is the vehicle enters the inspection point, Pitcrew does a pre-screen of that, and then there's basically a traffic light to flag that vehicle for more detailed inspection. Allowing that targeted mechanical and brake inspection. Matt might be able to be better on the data with this, but it was about a 2-year case study. It was greater than 95% of the flagged vehicles were issued defect notices off the back of a Pitcrew inspection. So rather than what was being done previously, where you may have a throughput of 10 or 12 vehicles a day on a brake force roller tester, and it's a bit of a potluck random breath test type situation, you might get 1 or 2. Those compliance inspectors, basically every vehicle they were testing on that brake force roller tester was getting a defect notice. That probably doesn't make us particularly popular in industry, but in terms of road safety, it's and proving the technology works, it's a good outcome.
Well, the options are either you buy one.
Yeah. In terms of commercial operators using this stuff, right now we're really working with a very specific set of operators that are either very technology forward or have very specific use cases. So things like dangerous goods transport or underground operations or specific safety concerns or major maintenance issues like very remote operations. So in this situation, over a 12-month period, the system flagged 566 issues that would have otherwise gone undetected. The way they operated this was as the vehicles came into the mustering depot, it would be pre-screened as they came through the gate, and then the maintenance technician would be getting an SMS, and it would say, you know, this registration, trailer 3, axle 4, right-hand side, suspected brake fault or whatever, and you'd get a 10-second video clip there, be able to go out there and sort of action something while everything was still hot and you could still smell and see what was going on. So, you know, more than one every day of an actionable outcome from that. Over that period, they were basically sending out a roadside technician about once a week to action something related to a wheel end fault, and basically went to zero over the course of that 12 months. So very commercially high value outcomes from that. It enabled their techs to move from like routine, you know, I need to inspect this vehicle this week because that's what's on the schedule, to just everything was targeted work. Really changed the way they operated the business.
And maybe in a bit of context like that, roadside drive
could be 4 or 5 hours each direction. Yep, it's a lot of downtime for vehicles, a lot of lost time. Then you've got fatigue management issues. You've got everything just stacks on it when you're in that sort of operating environment. So just talking about, again, I touched on mining. Our customers in mining, we've got systems all over the world, from sort of northern oil sands in Canada through to Colombia and Brazil and all over the world. And one of the things we've come across is just the craziness of the operating conditions we see. You know, we've had days where there's been literally 100-degree temperature spread between systems in the Pilbara and the oil sands. So we've got plus 50 in the Pilbara and minus 52 in the oil sands. So we're experienced in sort of dealing with these sort of challenges. I mean, you can see down here, this is an in-ground camera in an underground mine in Mongolia, and just how horrible those sort of mud and situations can get, and how do we deal with this sort of stuff. So there's I guess a lot of mechanical engineering that needs to go into how we work in these constraints. You know, if we're talking in Western Australia or Queensland, it may be dust, it may be, you know, the afternoon sun. All of those environmental considerations are things that we've had to work with and understand. I lost. Oh. Yeah. So what this is showing here is we're partnering with sort of leaders in very niche specific technologies. So this here is a company out of Canada that manufacture lens cleaning technology using very specific lens coatings and then non-scratch cleaning mechanisms. So you can't use things like a washer and wiper. You'll end up with more mud on your camera. So this is a completely dry cleaning mechanism. So these sort of technologies are what enable us to give reliable operation in remote environments. At the end of the day, you know, our goal is to improve safety and remove technicians from being out in the field doing inspection work if they don't have to be. So having a technician out cleaning a camera because it's dirty every 2 weeks is not where we want to be as well. So we're working really hard to sort of build out the technology to make sure this stuff is as reliable and bulletproof and low maintenance as it possibly can be. At the end of the day, it's all about driving triple bottom line outcomes. So it's making sure your drivers are kept safe on the road. It's making sure you're meeting your duty of care and chain of responsibility requirements around public road user safety. It's about improving the maintenance of your fleet and the efficiency of that maintenance process, keeping the vehicles operating. The compliance and regulation piece is a big one. So we're seeing some of our customers pushing closer towards using our system as an automated reporting platform. So eliminating the need for some of the driver logbooks that are currently, you know, not to be rude, but some of those are an absolute work of fiction. You know, like the driver's meant to be measuring tyre temperatures and things out in the field. A lot of that stuff can be done a lot better with automated reporting. And automating that process is again, not putting your drivers out in the sun on the side of the road. You're getting better results with less input from your team. And by driving better component utilisation use, there's a whole bunch of environmental outcomes that will come out of that. Certainly in the mining space, with the tyres, you know, the big tyres, there's about 30 tonnes of life cycle carbon tied up in each one of those tyres. And so there's some very clear carbon accounting that can be done around, you know, scope 3 emissions. we're yet to get to that point with a lot of this on-road calculation, but there's absolutely from a carbon reporting standpoint, there's a lot that can be done around environmental outcomes of better maintenance practices. Thank you. I've got some photos and videos of the mining stuff if anyone's interested that I'm after this. But yeah, I thought I'd throw out the questions.
Go ahead, Dave.
Yeah, what sort of variance do you get from your best of best flow temperature reading to say worst of worst before your intervention starts with the self-cleaning? What sort of variance do you see in the real world?
The actual measurements. Yeah. So I mean that's probably one of the big things is we try to rely on absolute temperatures as little as possible because there's so much variability in terms of if you've got a vehicle coming in that's done 10 Ks versus 100 Ks under hard braking, all those absolute temperatures are going to be totally different between those vehicles. Similarly, the braking between your disc brakes on a prime mover versus your trailer brakes, totally different. So typically what we'll be looking at is relative deltas. So it'll be, across the vehicle or longitudinally on the vehicle and looking for relative changes. So if you're coming down the left-hand side of the vehicle and you've got, 30, 30, 30, 30, 55, 30, 30, 30, that's it. That's an issue. So, it's a 15-degree delta there. Whereas, by itself, a 55-degree brake, who cares, right? So a lot of the algorithms are based around those relative differentials. It gives us much more reliable results.
And it's easier computing as well.
Yeah.
Okay, thanks.
Where do you, so, I keep saying you're one of the few actual useful AI out there, apart from lots of chatbots. Where do you see this going? Where do you see the technology moving to?
Yeah, I mean, for me, you look at this with, you could argue about timelines in terms of driverless vehicles, right? It could be 2 years, it could be 20 years before we've got the roads inundated with driverless fleets. But I think at some point we are going to see driverless vehicles everywhere. And I think the lion's share of investment and development to date has been poured into the driverless driving systems. And I guess our experience in mining shows that, drivers do a lot more than just drive the vehicle. Like all of that ancillary stuff of just walking around looking at stuff. Like there's value in that. Getting in the car and going, that looks stuffed. Taking away the driver to do that, you end up, there's all these unforeseen consequences of that. And so I strongly believe that the next big thing that will have to happen around driverless vehicles and autonomy will be the supporting systems, the supporting infrastructure, the inspection processes. Similarly, as you see, like if you're a truck fleet operator today and you're investing in driverless vehicles, you're, between drivers and alternative fuels and whatnot, you're probably looking at about 40 to 50% of your cost base shifting at some point, right? You take away driver's costs, you take away fuel costs, whatever that looks like. So the economics are going to change in road freight. Flip side of that is you're also going to end up with higher capex costs because you're investing in vehicles with all of this sensing and technology on there. So from driving your P&L of your business standpoint, you're going to need really high utilisations. So it's going to push trucking to be even more like the airline industry where it's all about turnaround times. You won't want anything parked for too long. So again, automating those inspection processes, being really on top of predictive maintenance and proactive maintenance is going to be really key to running a profitable organisation into the future. In terms of where we're going, that's where I want to be. I want Pitcrew to be a key player in that space around keeping autonomous vehicles moving when we head down that path.
There and follow on the system itself, what limitations does the hardware pose for it to be so you can kind of detect everything or most things?
Yeah, I mean, so the US is kind of more progressed than anywhere else in terms of pre-screening inspections for vehicles, and there's standards there now around if you're a automated driverless vehicle, you get a 24-hour clearance to not have to pull into wayside inspection stations and things like that based on a pre-start inspection. It's someone signing away their life and saying we've done a really detailed inspection of this vehicle. And that inspection checklist is something like, 230 inspection points. Probably about 180 of those can be done in a non-contact visual or thermal way, right? So there's still a bunch of stuff that you physically need to go and